Using a sketch diagram, explain a definite of an integral. Actually, that was an error. It was supposed to be explain a definite integral. I've already explained it in the other question. So a definite integral, we use a diagram. This is, you have your x-axis here, you have your y-axis here, so you could be having your f of x here. If it's definite, it means you have an x value. So that is it, which is representing area. So integral from a to b of f of x dx. That's what you are supposed to give me for 2 marks, guys. And then question number 2, evaluate the following integral. So the first one is 4x plus 2 over x plus 4 dx. Guys, I said that before you resolve into partial, check the power of x. The power of x in the numerator should be of a lower degree. As you can see, the power of x in the numerator here is of the same degree with the power of x in the denominator. So we will first of all start by division, long division. So dividing this, what do we get? So 4x plus 2, if you divide, I need to get a 4x here, meaning I'm going to multiply with 4. So multiplying here with 4, I get 4x. Multiplying this, I get plus 8. So subtracting 4x minus 4x, this gives 0. 2 minus 8, this gives minus 6. So what do I have here? So I have 4 plus minus x over x plus 4. This is what I have. So this is what I am going to integrate. So integrating this, what do I get? If you integrate 4, you get 4x. Minus, if you integrate 6 over x plus 4, you get ln x plus 4 plus c. This is your answer. I hope we are together. Only a few of you managed to get that answer. 8 or 16, let me see. Someone is asking 8 or 16. 2 minus 8. Where is 16 coming from? 16, thank you. This is 16. If you, this and this gives you 4x, this and this gives you 16. So this should be 16, not. So 2 minus 16, that will give you minus 14. Thank you for that. So this is minus 14. This is minus 14. Thank you for that. So that is it. Only a few were able to get that answer. So note that that's how you go about it. Before you resolve into partial, check. If the powers are the same, then you need to first of all divide. Or if this power is higher than this one, then you need to, because this one needs to be, on the numerator needs to be lower. Okay. The next question, it's actually number 2 still. It's question number 2 still, but B. It says integral from 0 to 1 of x squared exponential x dx. So let this one be your u, let this one be your dv. We have already checked using Liate. We have algebraic and exponential, so the order is fine. The formula is uv minus integral of v du. Now what is our u? Our u is x squared. What is our dv? Exponential x. So if u is x squared, what is du dx? What is du dx? Du dx is 2x. And if dv is exponential x, what is v? V is also exponential x. So replacing these values into the formula, what will we have? So u is x squared, v is exponential x, minus integral of v exponential x du. Now, making du the subject of the formula here, we have 2x dx. So I want to rewrite this in a better way. So I have x squared exponential x minus, let's take the 2 outside. We have x exponential x dx. I've written it in the form Liate, where algebraic should come before exponential, so that I use integration by parts again. Let this be u, let this be dv. Some of you are not doing this last part. We do it again, the integration by parts. If u is equal to x, then what is du is equal to x? Then what is du dx? Du dx is 1. dv is equal to exponential x. What is v? Exponential x. So we are going to replace again in the formula. So we have x squared exponential x minus 2. Most of you are actually leaving out this minus in your transactions. You are leaving out this minus. So minus 2 outside, and then uv, u is x, multiplied by v. V is exponential x minus integral of v dx, and dx is our du, uv minus integral of v du. Our du is dx in this case. So don't forget this minus here. So many of you left it out. So this is x squared exponential x, open this bracket, minus 2x exponential x, minus and minus will give me a plus. Then we have 2, integrating exponential x, we get exponential x. Were we given limits? Yes, the limit was from 0 to 1. So what's my final answer? Replace with 1 first and then replace with 0. So replacing with 1, I have 1 exponential 1 minus 2 exponential 1 plus 2 exponential 1 minus, replacing with 0, I have 0, 0, and then replacing here with 0, I have 2 exponential 0. So if you evaluate that, you should get your answer. If you evaluate that, you should get your answer. Please let me know if you have a question up until that point. Let me know if you have a question up until that point. We have less than 1 minute, so I will let you guys rejoin.